Yes, students. Now, based upon the free fall equations, we will do some questions. So first question is, a car falls off a ledge and drops to the ground in zero point 0.6 seconds. 0.6 seconds it drops. We can say this is some surface. The car was coming, it drops and it comes to the ground in time is 0.6 seconds. The value of G he has given is 10 meter per second square. Okay? Actual value is 9.81 meter per second square. It's close to 10. So for easy calculations, he has asked to take this value. For simplifying calculations, number one, we have to calculate what is the speed of the striking car on the ground. When the car will strike the ground at this point, what will be the speed? Simply he is asking final velocity v. So students, when the car starts to fall, when the car starts to fall at this point, can anyone tell me what is u, initial velocity? Hello students.
Zero.
See, initially the car was having velocity in this direction, not in this direction. We are talking about the velocity in this direction. So here in this direction, velocity was zero, right? Slowly the velocity increased and here the final velocity is v. We want to calculate it. So how can we calculate? Yes, students?
First equation of free fall.
Yes. We will use a
V is
equation.
equal to U plus GT.
Correct. U plus gt. That is equal to u is 0 plus we will take g as 10 into time is 0.06 seconds. So we got it. The answer is 6 meter per second. Second, what is the average speed during 0.6 seconds? Average speed in 0.6 seconds. Yes, students, how can we find the average speed? So, if we imagine that the car is following in a straight line, we can imagine the car is not obviously falling like this, you know, the car is falling in a straight line, then we can replace this word to avoid confusion with the velocity also. What is average velocity? Okay. All right, it's better to write velocity. So what will be average velocity? Anyone? What is the formula for average velocity? Average velocity. You must see the previous videos, students. U plus V divided by 2. So initial velocity is 0. Final velocity is 6 by 2. That is equal to 3 meter per second. All right. Now, third, he says, how high is the ledge from the ground? How high is this ledge from the ground, this point? We want to calculate what? Anyone?
Distance.
Distance S. So which equation we will use? S is equal to
Second.
ut plus
UT plus
Half
half
GT square.
2GT.
correct. So can I ask any student why we are not writing A here? Why we are not writing A? Anyone? Yes, Mansimrit. Why we are not writing A?
So because here we are use as a is also constant, and we are using this g is the acceleration due to gravitation.
You should say because it's a free fall. In the free fall also, G is constant. That is 9.81 meter per second square. And originally this equation S is equal to ut plus half at square was also derived for constant acceleration. Here also acceleration is constant. So we can use this equation for free fall also. This is the answer. Anyway, good. So on the horizontal surface, we take A. If it is constant, then we use this equation. And in the free fall, we can replace A with G. So we can immediately calculate U is 0. This becomes 0. Then half into A, as he has given 10 into T square, 0.6 square. Am I right? So this is equal to 1.8 meter. It's very nearby. 1.8 meter. That's why the time is only 0.6 seconds. Fine. This question is over. Adan. Students, he says object is thrown vertically upwards. This is a ground. This is an object. It's thrown vertically upwards. Okay. And rises to a height of 13.07 meter. So S is given. You can say H or S, no problem. Now it rises to this height. Now what we want to calculate, number one, the velocity with which the object was thrown upwards. Now here students, you can't say when the object is thrown upwards, its velocity is zero. It was thrown with the velocity. Because of that velocity, it rises high. Am I right? But when you are dropping an object from here, then it is possible. Let's say you have a brick in your hand. So let's say you are standing at 10-meter high point. You have a brick in your hand. It's possible that the velocity is zero. As the brick comes down, its velocity will increase, and with some final velocity v, it will hit the ground. But when you are throwing something upwards, there is an initial velocity, and that initial velocity we want to find out. Any student can tell me how we can do it? He has given to how much height this stone or this object is rising high. Anyone?
First,
V is equal to U. No, because
Second
first
equation.
equation is V is equal to U plus GT. Time is not given. Initial velocity, final velocity, nothing. We
The
can't use
third
this equation.
third,
Anyone?
third 2gs
Speak
is
loudly.
equal to 2gs is equal to v square minus u
Perfectly
square.
right. 2gs is equal to V square minus U square. Now, Falgun, can you tell me what is V in this case?
V0
Correct. Beautiful.
meter per
Because
second.
when this stone, anything which you throw upwards, after some time, the final velocity becomes zero. That is the maximum height. At this point, the object has achieved maximum height. This maximum height will depend upon with how much force you throw it. With how much more velocity it's thrown, more will be the height, right? So when the projectiles are thrown or when the rockets are thrown upwards, so they have a lot of force and they have constant force. So they rise very high. They rise so much high they reach, orbits of different planets. You know that moon very high. So here H maximum will be there. V will be zero. Good. So what is U that we have to calculate? So it will be 2. Let's say again we take G as 10, or let's say you take G as 9.8 only. Okay. Now students, one more thing. You know, how many students believe that acceleration is a vector or scalar? Acceleration.
Vector.
Correct. That
Acceleration
means
is vector.
acceleration has direction. Suppose you have this vector. So what will be the value of this vector? Suppose this vector is A. Then what will be this vector? Minus A when its direction is reversed. Remember that. Okay. Now, in which direction G acts? Can you tell me? This acceleration is a vector. In which direction G acts? Does the G acts upwards or G acts downwards?
Upward.
See, student, if the G was acting upwards, all the objects instead of
Down.
instead of coming towards center of Earth, they will be flying upwards. like fire. You see fire. Fire never goes down. It defies gravity. It always goes up. Very strange.
Up.
But all other objects, they go down. Okay. So you think, students, why the earth is not able to apply gravitational force on fire? You see, this is a matchstick. You light it, the flame will go up. The flame, why the flame does not go down? So there's a reason related to density. In the next video, you please answer this question. Okay. So we have understood that G always acts down. But students, here the object is going upwards. So can anyone tell me what should be the value for G we should take?
Minus 9.85.
Correct. It will be minus 9.8 meter per second square. Because of this, so you can say this is retardation, right? You can say this is retardation, or you can say this is deceleration. And because the acceleration is negative, or you can say the force acting on the object everywhere when it's going up is negative, and because of that its velocity decreases, 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 and finally the velocity becomes zero. All right. It's like, you know, there's a car, slowly, it's moving, slowly it's moving, the engine is off, and then you apply brake. The brakes are applied in the opposite direction. Acceleration is in opposite direction. Finally, the car comes to rest. Same way, it's happening here. So now we can write 2 into what is the value for G? Pranav?
Minus 9.81.
Minus 9.81 into S. S is 13.07 is equal to V square. 0 square minus U square. We can calculate U from here. So that would be exactly 16 meter per second. All right. And second question is, students, what time taken by the object to reach the highest point? Time taken by object to reach this point. Any student, which equation we will apply?
First equation.
Perfectly right. Because now we know U, V. V is 0. We also know U, 16 plus. Again, students, yes. What will be the value for G?
Minus 9.8.
Correct. Again, minus 9.81 into T. See that, that's why the T will come positive. If you take G as positive, T will come negative. Time can never be negative. That's the beauty of maths. So it will be minus 16 divided by minus 9.81, right? So this is equal to uh, minus 1.63 seconds. All right. So we have done this also. Okay, students. Now, yes, are you enjoying? Are you
Minus
learning?
1.
Yes,
Huh?
sir.
Okay, you're enjoying. Now it says a ball is thrown vertically upwards. Ball is thrown vertically upwards. Okay, with a velocity of 25 meter per second. Okay, now G is, he says, take G as 10 meter per second square. Okay, but actually we will not take 10, we will take minus 10 because G is acting downwards, but the our stone ball is going upwards. Ball is thrown vertically upwards with a velocity of 25 meter per second square. G is this. Then calculate height it achieves. Height it achieves. So students, tell me, can you calculate this? Now you can calculate the height. Hello students.
Yes, sir.
Yeah,
Yes,
good.
sir.
So you calculate. And what is the time? Time taken to return back. Time taken to return back. So that will be equal to T1 plus T2. Right? So Well, they'll be same, so it will be 2t. So if you just calculate the time taken from here, go here to here is t, simply multiplied by 2 to get this time. So students, I want that you watch this video again. If you leave anything, and tell me by today, maybe by evening, I want that in the comment section you should write the what height achieved, answer, and the time. So let me see who will answer them first. I wish you all the best. Have a nice time.